ago. I can still remember how that music used to make me smile. And I knew if I had my chance,
Good
that
morning,
I
good
could
afternoon,
make
good evening,
those
whatever
people dance,
the
and
case may
maybe
be.
they'd
We are
be
back,
happy for
and
a
better
while.
than ever. American Pie by Don McLean, an oldie but a goodie.
But
Somewhat
February
appropriate
made
because
me shiver.
we're talking about logarithms today, which used to be calculated with the help of a slide rule, boys and girls. The calculator before there was a calculator. Awesome sauce. Let's get to it, shall we? Oh! Blank space right there. Let's say we have the equation 10 cubed is equal to 1,000, which is true. 10 times 10 times 10 is equal to 1,000. A logarithm is another way to write exponential expressions. Okay, so we could say the equivalent of saying this is the logarithm base 10. Notice the bases are the same. The base of the exponent is the base of the logarithm of 3, of 1,000 is equal to 3. So the 3 is the logarithm, which we will call log. The 3 is the exponent, or the power, right? So the logarithm is the exponent, or the power, that equals 1,000, okay? And so we can use this relationship and what we know about logarithms to solve equations. For example, if I said 2 to the x equals 8, you would immediately say, I hope, oh, well, x equals 3 because 2 cubed equals 8. But what if I said 2 to the x equals 7.96201? Well, we have no idea. And we couldn't figure that out in our heads. It would take us, well, we could, but it would take us a very, very long time. Well, to the rescue come logarithms. So let's get to it, shall we, with some other examples. But I want you to see, well, no, before I go to the next page, this is the relationship between exponential form and logarithmic form. So this is logarithmic form, log form, and this is exponential form, for obvious reasons, I hope. Generally, a to the x is equal to b if and only if, otherwise abbreviated like that. Both of these are if and only if. Log base a of b is equal to x. Exponential form, logarithmic form. Yes? Yes. Okay? So we have that relationship. A little bit backward, they just wrote the x first here, but it's on your formula sheet and you will always have that. Okay? So without using a calculator, find the log of 100. Okay? Now, 10, the base of 10 is one of the most often used logarithms, a log with a base of 10. So if there is nothing here, if there is no base shown, then the base is 10. We just don't write it. Okay? So if you say log base 100, then it is a base of 10. So to evaluate it, we're asking, I'm going to go ahead and write the base in there now. Remember, when I'm finding a logarithm, I'm finding an exponent. Okay? I'm finding the exponent where when the base is raised to it, it equals the 100 here. Okay? So if you haven't figured out that this is equal to 2 yet, one way you can get a better view of it is to say, okay, I'm just going to let it equal x. And once I solve for x, I have the value of the logarithm. And you can always go back to your formula sheet and look at the relationship. A to the x is going to equal b. A to the x, 10 to the x, is going to equal b, or the 100. Right? So 10 to what power equals 100? Well, 10 squared equals 100, so x is equal to 2. Okay? So let's do this one. Log of the fourth root of 10. Now again, I can't use a calculator to do this, or they asked me to. All right? Well, I'm going to set it equal to x again, and I'm going to start cleaning this up. And I'm going to recall that it's log base 10, yes. And let's see, I can write the fourth power of 10 as 10 to the 1/4 power equal to x, right? In other words, the fourth root of 10 is 10 to the 1/4 power. And hopefully you see that the answer is 1/4 right now. But if you don't, 10 to the x power has to equal whatever is here, 10 to the 1/4 power. Well, if they have the same base, the exponents must be equal, so x is equal to 1/4. So that means that the log of the fourth root of 10 is equal to 1/4. And I should have written that over here. The log of 100 is equal to 2. So let's take a look at our calculator with that. So our log key is right here with 10 to the x. That's pretty nice because it's a reminder that this log is base 10. So I got to hit Control Log, and I don't have to put 10 in there if I don't want to, because the calculator knows that the default base is 10. So if I just put in log of 100, you'll see that I get 2, and it throws it in there. And then again, log base 10 of the fourth root. So I can go here, fourth root of 10 is equal to 0.25. So I'll take a picture of that. We verified it. Here we go. Put it in our notes. Okay. Okay. So I am going to point something out here. Notice that in this particular, I'll do it in pink, for this particular problem, I had log base 10 of 10 to the 1/4, and it turned out being equal to 1/4. Okay, so this is one of the basic rules or laws, not laws, but rules, or hopefully common sense things about logarithms. If I have the same base and it matches this right here, then whatever the exponent is going to be whatever the logarithm is equal to, because of the relationship. 10 to the 1/4 has to equal 10 to the 1/4, therefore it must be 1/4. Okay? Same base, your exponent is the value of the logarithm. Okay, a couple more examples. Find x if log x equals 3. So that's really log base 10 of x equals 3 using the relationship 10 cubed is equal to x. So 1,000 is equal to x. Okay. So log base x is approximately equal to negative 0.271. So that is a base 10. So that means 10 to the negative 0.271 is approximately equal to x. And then I'll just do that on my calculator real quick. 10 caret negative 0.271. That's not a point. 0.271. Boom. And there we go. So we'll put that on there for us. Bam. And so we have to 3 sig figs, that would be 0.536. So x is approximately equal to 0.536. Okay, next example. Write an equivalent exponential equation for log base 10 of 1,000 equals 3. We've been doing that. In fact, I believe that was one of my opening examples, although I start with 10 cubed. 10 cubed is equal to 1,000, and that makes perfect sense. And B, 3 to the fourth equals 81, so now I have to convert that to a logarithmic equation. So you just have to think about it. The base of the exponent is 3. That is the base of my logarithm, log base 3. So anytime there's a base other than 10, we have to write the 10. We have to write that base, whatever it is. Log base 3 of 81 is equal to 4. 3 to the fourth is equal to 81. Okay? Fairly easy peasy, I hope so far. So now we're going to evaluate these. Okay? Maybe we'll have to use our calculator, but we're going to do it algebraically as far as we can. Log base 2 of 16, I'm going to say that's equal to x. Using my relationship, 2 to the x is equal to 16. And hopefully you know that 2 to the fourth power is 16, so that means x is going to have to be equal to 4. So log base 5 is equal to 0.2. Let's let that equal x. Okay, and let's think about this for a little bit. So 5 to the x must be equal to 0.2. Well, I can do this I can actually do this, or you can actually do this. If you convert this to a fraction, I think you'll see it. 5 to the x is equal to 2/10, which is 1/5. Well, 1/5 is equal to 5 to the negative 1, meaning x would be equal to negative 1. Okay. This one, I'm going to, I suppose, yeah, I'll go ahead and let it be equal to x, but I'm going to do a lot of manipulation here. So log base 10 of, that's going to be 100 to the 1/5 power. Okay, and I have a base 10 here, and I can write 100 as a base 10. So watch what's going to happen here. Log base 10 of 10 squared to the 1/5 is equal to x, or log base 10, 10 squared to the 1/5 is 10 to the 2/5 is equal to x. So I should be able to look at this right now. Oh, same base as what I'm taking the logarithm of, or of the argument, is equal to the exponent. So I know that x is equal to 2/5. And if you don't see that, well, look at the relationship. 10 to the x has to be equal to whatever is here, and that is 10 to the 2/5. Same base, exponents must be equal. And that was it. That's the last thing that I had for you. That's the beginning of our journey into logarithms. Very, very useful mathematically. I am very excited to get back into it here with logarithms and to explore further. I know you are too. Back to a little bit more American Pie. And with that, I am out!
And I knew if I had my chance that I could make those people dance, and maybe they'd be happy for a while. But February made me shiver,